All right, y'all. So the next thing we're going to talk about is agglomerative and partitioning algorithms. So the ag algorithms is what I'll call these for short, just because I botch agglomerative so much. Ag algorithms is this idea where we continually build on distances between two data points. So we're not trying to measure the distance to a centroid. We're trying to measure the distances between data points. And then once you take that into a play, how do you calculate distances between clusters and all that? So here's the base of an agglomerative algorithm. Treat each observation as a cluster. Calculate the distance between each observation, okay? Combine the data points into a single cluster and repeat till there is only one cluster. So the idea is this. Start with every data point as its own cluster. Calculate the distance between every data point. So you've got n data points. You've got to calculate n times n minus 1 over 2 distances. So you only need to calculate the distance between every data point and every other data point, right? So here's the idea. When we're looking at this, what we're going to do is we're going to treat each observation as a cluster, calculate the distances. Whatever two data points are the closest out of all possible combinations, we combine into a single cluster. Then we treat that cluster as its own data point and continue to move. Now, how we treat that cluster as its own data point is really important because it's what defines another piece of the clustering. So before I told you, okay, pick your method, pick your distance metric, pick your method. But in ag methods, there's a third thing you've got to pick. You've got to sit back and you've got to say, okay, simplistically, these 4 steps can be broken into 2. Think of every data point as a cluster and repeat this until there's only one cluster. Calculate distance between all clusters, combine nearest clusters into a single cluster. Now, the big question, the third piece we add in ag algorithms is how do we define distance between two clusters? And here's a few ways to do that. The minimum distance between 2 points in different clusters. Well, we talked about that before. That was my hand example I gave you, where I've got 2 data clouds, and these are my 2 clusters, and I'm going to calculate the distance between the 2 clusters as the 2 closest points, which would in this case be my thumbs, right? Then we have complete linkage, which is the maximum distance between 2 data points in different clusters, which would be pinky to pinky, right? So when I'm looking at those type of things, when I'm seeing this type of thing, this is the next thing I have to define. Not only do I have to define a distance, but I have to figure out what that distance corresponds to in an agglomerative algorithm. It's not as simple as point to a middle, which is what a partitioning method may look at. It's complex, but you have all these differences. So it's the maximum difference, okay? It's the average difference between 2 points. So what you would do is you would calculate the distance between all the data points in the 2 clusters and then take the average. You can do a weighted average. You can do a distance between a centroid. And all we call a centroid here is just some way to estimate the center of the cluster. Or you can do the distance of the medians. Really, it's up to you. But what this is referred to as a linkage, okay? A linkage. Now, this linkage is a big deal. And the reason this linkage is a big deal is because it links the 2 clusters. That's the reason it's called a link. But you could have 2 clusters that are really, really close together in minimum distance, but really far apart in maximum distance. Things that don't look like circles, but are all spread out. Average distance, it could be biased. We know averages can be biased. A distance to a centroid. Well, how do you calculate a centroid? You know, distance between medians. Okay, does medians make a lot of sense? So when you're looking at this and what you're seeing and how you approach it is extremely important. Now, what we're going to see through the next couple examples is I want you to go try some things. I'm going to show you one way, but then I want you to go try 3 more. That's what I'm asking you to do. That's how I want you to get hands-on with this. Because what I want you to see, and the only way you can see it, is to start looking at the changes that are made. In certain data sets, you may see large changes. In other data sets, you may not. So when we're doing these type of methods, and when we're doing this type of analysis, go try something. That's what I want you to do. That's my challenge to you. The reason we've made, compared to BUDA535 that is, the reason you've seen these classes get shorter is because now you understand the basics. So go try something. Go work on this. Try something in these data sets. With all these different linkages and all these different distances, you have a ton of combinations you can try. So go investigate. Take a shot at it and let me know if you have any questions.